Welcome to the second part of our introduction to social networks and social network analysis. We finished the previous lecture by looking at the concept of density. Density indicates how connected a network is. If everyone is connected to everybody else, we say that density is at maximum equal to 1. In general, for real networks, density is never equal to 1, and it is lower in the case of networks in cities. It is much lower than 1. The concept of network is important because it tells us that networks are not spatially symmetric, meaning that density will change over the area of the network. And this is important. This is important because it leads directly into the concept of weak ties. Weak ties, if you look at the representation on the left hand side, in which we have a community, a network, let's call it community 1, and a network, let's call it community 2, what we notice is that networks will be internally highly connected, density will be relatively high in both networks, but then there will be only a few links that bridge the two networks. We call those few links weak ties. So weak ties occur in areas where density is much lower than the rest of the network. In general, weak ties characterize links between separate different networks. Very quick application for you is to look at the graph on the right hand side and identify which, in your opinion, are the weak ties in this network and which instead are not weak ties. By converse, they are strong ties. Where does the idea of weak ties and strong ties come from? The idea of weak ties was suggested by a sociologist called Granovetter in 1973 papers called The Strength of Weak Ties. The idea came because Granovetter was interested in how people found a job, and especially was interested in how the initial information that a certain job was available at company X. Granovetter expected or assumed that information came from people with whom the candidate had frequent contacts, colleagues, friends, family. What he found instead is that information came from unexpected conversations that that individual had with people waiting in the same queue, or people just met in a cocktail party, or conversations sharing a cab. Conversations that were unanticipated. This led Granovetter to formulate the idea that conversations between people that don't know well, don't meet frequently, are conversations that bridge the difference between distant clusters, these distant networks. Conversations that bridge individuals that do not belong to the same cluster tend to have a non-redundant informational base, meaning tend to happen between individuals that do not share the same friends, the same knowledge, the same information. Because of that, if those conversations happen, the knowledge that flows along the conversation tends to be new to either party. This led Granovetter then to formulate the idea of ties or links based on the novelty of informational content. So he said weak ties are informations that happen between individuals belonging to different networks and hence having different informational bases, and instead strong ties are ties between people who share frequent contacts, close friends, close colleagues, family. In conversations characterized by strong ties are conversations that come from people who have the same or similar informational basis. Why? Because if you share lots of information with your close friends, the result is that the network per se will share the same knowledge and the same information. On the contrary, people who belong to different networks tend to have different information and different knowledge. So the idea of weak or strong ties is the idea that links that bridge different networks tend to carry high informational and knowledge novelty. Weak ties are very important because imagine that you want to coordinate the action between different networks that are highly connected within but weakly connected from one another. Let me give you an example. The example of the supply chain in Toyota. In 1989, I think, one of the suppliers of Toyota, the company called Aisin, had a devastating fire. Aisin was producing a special type of valve called the P valve, and it was the only supplier. Because Toyota had a just-in-time system, which basically means they produce what they need, they had no warehouse, no spare parts. So the production of Toyota grounded to a halt in a short time. Now, what happened among the other suppliers of Toyota is that they self-organized, and in the space of a few days they restarted production of a component they were not producing before. That happened because engineers in the supply chain of Toyota, engineers that knew each other, but engineers that belonged to different companies, managed to get together and shared knowledge designs together with Aisin's engineers, of course, but without the direct control of Toyota. They did that because a network of weak ties characterized the supply chain of Toyota. So in a few days, production restarted at Toyota. Notice that the coordination of companies that belonged to Toyota supply chain, but were not forced, were not ordered to coordinate around the production of an item they didn't know before, or they didn't know how to produce, was made possible by the presence of weak ties among those companies. That, to a certain extent, this is a specific Japanese characteristics. This leads then to the important concept formulated by Duncan Watts in a beautiful book called 6 Degrees, The Science of a Connected Age, that weak ties not only are characterized by the fact that they're informationally rich, but weak ties also make possible the coordination at a societal level between different networks. So social coordination is made possible by weak ties that are less frequent, or by ties that are less frequent than strong ties, but are highly informationally rich, as in the case of the Toyota Aisin fire. An interesting evolution of the idea of weak ties has been proposed by sociologist Ron Barth. Ron Barth noticed that the lack of a weak tie between two different but complementary networks that need each other is a structural hole, and people that can sit in that position and connect the two networks can achieve a position of power because they can broker information flows between two networks. An example of this is provided in the graph. In the graph you have the connection between influential, powerful families in the Florence of the 16th century, 16th and 15th. There you notice that families can be connected by multiple types of ties, whether by marriage or by trading relationships. What is interesting is that that network is divided into sub-networks. The network at the top, that one, is the network of aristocratic families, tied mainly by marriage relationships. And the network at the bottom is the network of trading bankers' families, essentially the new bourgeoisie in Florence, tied not only by marriage family but also by trading commercial relationships. Then what you notice is that there's just one family that connects the two. That family was the Medici. The Medici were at the same time traders and bankers and part of the aristocracy, and the Medici came to play a fundamental role because they connected those two networks. The fact that the Medici came to dominate the life of Florence for 3 centuries, according to John Paget and Christopher Ansel, is due to the fact that they rose to power because of their position that covered a structural whole in two networks that were needed to dominate, well, to coordinate the action of political, commercial, and military action in Florence. So structural wholes are effective because they can coordinate different networks that are necessary to run, in this case, a city, a state, an enterprise, or another type of organizations. Structural wholes may both hinder or facilitate innovation. They can hinder innovation because a person sitting in the middle may decide to withhold some information, or may they facilitate innovation because that node can broker the right type of information to create economies of scope and scale between two different networks. Another important concept in social networks is the idea of distance. The idea of distance is basically how difficult, how easy or difficult it is to connect two different nodes in a network. Let's say node 17 and node 7 have got distance of 1 because there's just one link among them. But if you take two extreme nodes in this network, node 17 and node 15, the distance is 5 because I need one link between 17 and 7, the second link between 7 and 1, a third link between 1 and 9, a fourth link between 9 and 33, and a fifth link between 33 and 15. The concept of distance has been used to ask some apparently silly questions, like what is the average distance between any two random individuals on planet Earth? This idea has given rise to a huge literature and also to films and other intellectual activities. In a theater play by John Guare called 6 Degrees of Separation, which is also a movie that is represented there, basically one of the sentences is everybody on this planet is separated by only 6 other people, meaning you need 4 people in between the two extremes in order to send some information between A and B, if A and B are the extremes of that network. And that means that every individual on Earth is relatively close to any other individual. It's relatively close to us. It says, you know, the President of the United States, I going to live in Venice, it's anyone. The idea has been implemented, and you can play with it, in a subnetwork, which is the network of actors. How does it play? Let's say that there's a central actor. In this case, the central actor is somebody called Kevin Bacon, an actor not particularly important. But then you can ask the question, what is the distance between Kevin Bacon and any other actor in the world? The rule is that the distance is classified, is measured by a film in which the two actors play together. So in this case, the distance between Charlie Chaplin and Kevin Bacon is 3 because Charlie Chaplin played with Barry Norton in Monsieur Verdoux, Barry Norton played with Robert Wagner in What Price Glory, and Robert Wagner played with Kevin Bacon in Wild Things. So we've got you have 3 links that connect Kevin Bacon and Charlie Chaplin. Instead, there's 2 links between Marilyn Monroe and Kevin Bacon because Marilyn Monroe played in Let's Make It Legal with Robert Wagner. Robert Wagner played in Wild Things with Kevin Bacon. Notice, that was important, although certain individuals may appear very far away in a certain type of network, in reality the distance is relatively low. I've tried to play with it, and notice this. I search for the distance between remote actors. In this case I looked for the list of Nepalese actors, and you can find it here on this website. I selected one of them called Ramesh Uprati, and I found, although this actor is perfectly unknown to, I guess, most people in the Western world, the distance between Ramesh Uprati and Kevin Bacon is 1, 2, 3, 4, just one more than Charlie Chaplin. This is important. It is important because it basically says that if we want to reach any individual on Earth, in any companies around the world, the distance between us and them is relatively short. How did the idea came from? The idea came from a study that a sociologist, another sociologist called Stanley Milgram, did back in the 60s. Stanley Milgram wanted to see how many degrees of separations there were between A and B. In this case, A were people living in Nebraska and B was people living in Massachusetts. The rule were that if you received a letter, you should send it to somebody who was likely to know the final person. A certain number of letters arrived, and the average distance was about 6. The experiment has been repeated later on with the internet, and more or less they found similar results. About 5-6 degrees characterize the distance between any two individuals on planet Earth, irrespective of the type of network they belong to. Let me take one step back and re-examine the concept of link. We said that link characterizes the exchange of, or the flow between two nodes. But is there only one link between two nodes, or there may be multiple links? In general, two nodes may be characterized by multiple types of the roles that the nodes may be playing, or the multiple types of the content which is exchanged, or the information which is exchanged between the two nodes. Just to give an example, I can be friend with a colleague. We may go out to drink something together. We may, of course, we may be involved in the same project in a team, so the roles that we'll be playing will be the role of colleagues, or we may also be sharing some passion, say paragliding, and go out to do paragliding. So if you want to describe the links between those two nodes, you may need multiple links to refer either to the roles that the nodes will be playing, or to the content, to the informational content that the two nodes may be exchanging. This concept is captured by the idea of multiplexity. As an example, I would like you to apply the idea of multiplexity to the graph of the network of families in Renaissance Florence. Identify which node are characterized by multiplexing, which are not, and the nodes that you think are multiplexed, please try to identify if it is role multiplexing or content multiplexing. Very likely it will be both, and speculate what type of role and what type of content might be exchanged between the two nodes that you think are linked by multiplexity. There's no correct, there's no wrong or right answer. We are just speculating to see if the idea is clear or not. Another way to characterize networks is to look at whether at the structure of networks, whether networks are order or disorder. We already looked at it. Certain networks are hierarchical, other networks are not. When we say hierarchical, we refer to the fact that the structure is kind of pyramidal, and information flows in a hierarchical network, it must follow the hierarchical line. Hierarchical networks usually used to represent power or status, and they are important because they provide a map of how information flows or how information is supposed to flow in a network. Hierarchical networks are transitive, which means if A is the boss of B and B is the boss of C, A is the boss of C. The final concept I'd like to introduce in this lecture is the concept of cohesiveness. We say that the network is cohesive if it is difficult to split it into non-communicating subnetworks. For instance, if we look at the karate graph, we notice that it's relatively highly connected, but there are some points of fragility. Points of fragility are usually around the most highly connected nodes. In fact, if we look at node number 1, if we remove node number 1, we split the network into two parts. The small network on the left-hand side and the rest of the network on the right-hand side. The concept of cohesiveness also leads to the concept of the distinction rather than the concept of core periphery. If we look, for instance, at the network in the bottom part of the page, we notice that the center, the most cohesive and highly connected, is surrounded by relatively sparsely connected nodes. So the center will be the core of the network and the rest will be the periphery of the network. Most real networks will exhibit the property of being more cohesive toward the center and more toward the core, and relatively densely connected toward the periphery. Periphery may be important in social networks, but most of the action anyway happens in the core. The homework for this lecture involves two exercises. First, find examples of social networks. Use Wikipedia or Google or whatever, or you may also use the networks we used as examples for introduction part 1, and divide the links between the two groups of weak ties and strong ties. Second, try to map your own network of friends and put yourself at the center of the network. This is called an ego network. And then identify which links are characterized by multiplexity and which are not.